welcome to Chapter 3, where I want to tell you everything you need to know about parallels and perpendiculars. Okay, so let's pay attention here. So parallel lines, coplanar lines that do not intersect. All right, you've learned what parallel lines were a long time ago. We got a symbol for that. So for example, M and N are parallel. So I would say M is parallel to N. It's just kind of like writing two lines and make it look like they're parallel. So M is parallel to N. And this P right here, this line P, is called the transversal. Okay, a transversal cuts through parallel lines. So P is a transversal. And I'll write that here, transversal. I'm going to use that term a lot. Okay, so if I have parallel lines, any line that cuts through it is a transversal. So boom, P is a transversal there. Parallel planes, kind of hard to see in my picture there. It's planes that do not intersect. So I'm going to show an example with these guys right here. So if I look, I got two planes. Here would be them intersecting. Here would be them being parallel. So they'd extend infinitely in all directions, right? And they would never intersect. So these would be parallel planes. Okay, it's kind of hard to tell with that drawing. Nothing too fancy about that. Skew lines. Skew line. This is kind of our new term here. Skew. It's lines that do not intersect and are not coplanar. So I like to think of it as lines that are also not parallel. Any lines that are parallel are coplanar. So if I have parallel lines, they're also coplanar. So skew lines, let's try to picture some skew lines. Well, if I looked at AD, I'm going to look at the line AD right here. Are there any other segments in this cube that are skewed to AD? If I think of FE, that's on the same plane. That's on this front face, right? That's on that front plane. So not FE. It can't be DE. It can't be DE either because those would intersect, wouldn't they? They'd intersect at D. So it can't be DE. Could it be like GH? That seems kind of far away in the back corner there. Well, no, they're parallel, aren't they? I could cut a plane diagonally through this cube. Right? I could get a plane that goes, boom, diagonally through here, down through the H. I could cut a plane that's diagonal, so that doesn't work. So what line or lines would be skewed to AD? Well, can intersect, not coplanar. The only two that are like that would be CH and BG back there. So skew to AD would be CH or BG. Because if I think about those two, they would never intersect with AD because they're going up and down and they're behind it. And they're not parallel, they're not on the same plane. I could not draw a plane that both those would be on. So skew lines to AD would be CH and BG. So okay, in section 2, not much in section 1 there. Section 2, this is where we start getting into some things. So when we have parallel lines, I'm just going to write M and N again here. So if M is parallel to N, if M is parallel to N, and they have a transversal cutting through, I have a corresponding angles postulate. Corresponding angles are congruent. So basically, if I look at my parallel line M with the transversal, this guy in the top right, angle 2, is congruent to the guy that's in the top right with N and its transversal. So here's the top right one, 4. Right? They're both the top right angle, so we say they're congruent by the corresponding angle postulate. So angle 2 is congruent to angle 4. Which would also mean their measures are equal to each other, right? That's what congruent means. So if I think the bottom right up here, angle 3 would be congruent to the bottom right of down on the parallel with N. So angle 3 is congruent to angle 7. And then I have angle 1 congruent to angle 5 because the top lefts would be congruent. And then the bottom lefts, angle 6 would be congruent to angle 8. And they look like they should all be congruent, the ones that I wrote up. Okay, so and we call those corresponding angles because they correspond. They're in the same spots. Just like I said, 2 and 4, they're both in the top right. They correspond. That makes them congruent. So if I ever state in a proof that I have lines that are parallel, I can state that these following angles are congruent because they're corresponding angles, according to the corresponding angles postulate. Okay, we also have theorems. Basically, we use that postulate, and then we use vertical angles and some other things to prove that I have these other theorems. So we're not going to go through all that. We're just going to tell you what the theorems are. So same type of thing. If I have parallel lines, I'll just say M and N again. M is parallel to N. And they're cut by a transversal, which is right there. That means alternate interior angles are congruent. Alternate interior angles are congruent. Well, alternate, that means they're on alternate sides of the transversal. And interior, so alternate sides of the transversal. And interior means inside the parallels. Inside the parallel lines. So if I look at 1 and 2, they're on alternate sides of the transversal and they're inside the parallel lines. So we would say they are congruent. So angle 1 is congruent to angle 2 because they are alternate interior angles. Same thing with 3 and 4. They're on alternate sides of the transversal. They're inside the parallel, so they are alternate interior. So angle 3 is congruent to angle 4. Well, if we have an alternate interior, what do you think? We obviously have an alternate exterior angles theorem. So same thing, if I have two lines that are parallel, then alternate exterior angles are congruent. So 1, alternate side of the transversal, outside, exterior means outside now, so outside the parallel, so angle 1 is congruent to angle 2. And angle 3 would be congruent to angle 4, because they're alternate and they're outside, so exterior. Oh, screwed that one up. I want to say 4 is angle 3. Okay, good. So alternate interior, alternate exterior. We also have corresponding that we just did. So all those means that the angles are congruent. Well, there's one of them where angles aren't congruent, and that's our consecutive interior angles theorem. So if I have two lines that are parallel, they're cut by a transversal, just like before, then consecutive interior angles are what? Well, let's think about this. So if I have M and N, M is parallel to N here, what do you think I would know about 1 and 3? Gosh, what do you think I would know about 1 and 3? Well, let's see here. I know that 1 corresponds to this spot right here. Right? So for example, let's say that was 130 degrees. Wouldn't also this be 130 degrees? Well, if I look over here at angle 3 and that 130 degrees, don't they make a straight line? So angle 3 has to be 50 degrees. So what do I know about consecutive interior? What do I know about the consecutive interior angles? That's angle 1 and angle 3. Don't they add up to 180? Which we call what? Supplementary, right? Or supplementary, whatever you want to say. So angle 1 and angle 3 would be supplementary. So consecutive interior angles are supplementary. So measure of angle 1 plus the measure of angle 3 add up to 180. They are supplementary. Same thing with 2 and 4. Consecutive. So they're coming right next to each other. Interior. They're consecutive. They're not alternating now. They're on the same side. So consecutive. Interior means inside the parallels. So if I added 2 and 4 up, I would get 180. They're also supplementary. And when I look at my parallels, I have verticals, I got linear pairs, I got all kinds of things. But our 4 new things are corresponding, alternate interior, alternate exterior. Those all make congruent angles. And then consecutive interior, which we just covered, which makes them supplementary. So let's use some of this information to find some angle measures. I know that angle 11 is 51 degrees. I'm going to write that in here, 51 degrees. Find the measure of each angle. Tell which postulate or theorem you used. Well, for measure 15, if I'm looking at 11 and 15, they're both in the top right according to my parallels. Because here's a parallel. Transversal is right there. Well, I know that they're both in the top right, so they correspond. So I can say this is 51 degrees and corresponding angles. I know I should say corresponding angles postulate, but let's just say corresponding angles would be just fine. Then I look at measure of angle 16. Well, 16 is down here. I'm going to use green here. Well, if I compare it to angle 11, what do I know about those two? They're on alternate sides of the transversal. They're outside or exterior of the parallels. So I know that they're congruent, right? Because they are alternate exterior angles. And I like to abbreviate. What else do I notice about 16? Isn't it vertical to 15? So really, I know that 15 is 51. I could say 16 is 51 because of vertical angles. So we can use anything that we've learned so far. All right, let's bring some algebra into play now. If measure of angle 5 is 2x minus 10, and 7 is x plus 15, sorry, find x. Well, if I look at 5 and 7, what do I know about them? Let's see, bottom left, they correspond, so I know that they are congruent. So I can set these guys equal, right? So if angle 5 is congruent to angle 7, can I set them equal? So 2x minus 10 is going to equal x plus 15. And then we just go through our algebra, get our x's to one side, bring that minus 10 over to the other side. So I got x, that's gone, equal sign down, that's gone, 25. And that's all I'm solving. Sometimes I might want to find the angle measure here. It just says find x. So always go back and reread the directions. Let's do one more here. Find y. Measure 6 is 4y. 4 times y minus 25. And measure of 8 is 4y. Well, I don't have anything for 6 and 8. So a lot of things I can do here. I need to move some stuff around though. So think about, like, let's look at angle 6 for example. What else do I know about angle 6? Let's see here. Well, I got P and Q are parallel, right? That's what these symbols mean, that they're parallel, anytime I have arrows. And M and M are also parallel, but P and Q are parallel, N is a transversal. I also know that this is really angle 6 right here too, isn't it? Because it corresponds. It's the top right spot. So what do I know about 6 and 8 just by moving that there? They make a straight line, don't they? Won't they add up to 180? So measure of angle 6 plus measure of angle 8 would equal 180. So I should add these two guys up to equal 180 degrees. Equals 180. So really I'm adding these two guys up to equal 180. And now we go through our algebra. So I distribute 4y minus 100 plus 4y equals 180. Simplify, so 4y plus 4y is 8y, and I'm going to subtract that 100, or add 100 on both sides right away, equals 280, and we divide by 8, so y would equal 35. And it doesn't ask for angle measures, just asks for y, so I'm done. Last one, this gets kind of tricky. Okay, don't just think you can solve it without drawing in some lines or using some of the things that we've learned. I think the easiest way to attack this is to first get the angle measures that are all on the side where x is at. So for example, I want to figure out these two angles right here because they're on the same side as that x. Well, I know they're vertical angles, aren't they? So vertical to 125, that's also 125, and vertical to 105 is 105. And if I would draw in another parallel line right there where that angle meets and extended my transversals, so for example, this bottom transversal here would extend out to here, right? So I know that it makes a consecutive interior. That 125 makes a consecutive interior right here. So consecutive interior adds up to 180, don't they? So 125 plus what gives you 180? Or subtract there? Well, we got 55 degrees. And same thing, if I would extend the top transversal, I know that 105 and this spot right here are consecutive interior, so they add up to 180. I use blue there. And so I know 105 from 180 gives me 75 degrees. Well, and those two angles that I just found added together make x all together, don't they? If I would take everything away, well, let's add the 75 plus 55, which gives us 130 degrees. Isn't that what x really is? If I took away this transversal here, took away that, erased some of my stuff, and that's what that x was originally, 130 degrees. So that's my best route to go. Find the vertical, draw in another parallel. That always helps you. There's a lot of different ways to do this. You could bring a triangle into play. Man, tons of different ways. Okay, that's probably my easiest and quickest way to go, though. All right, so working on a couple different pages. First one, just naming the different types of lines, and then we're going to actually apply that geometry with some algebra.